All right, here we are with number 10. So I want to use this 10A as a example for how to use units to your advantage. So we read through, this guy has these two routes. One is 26% longer, but he can go 40% faster. Now the key here, by what percentage is his journey time reduced by taking the new route compared to the old? So first of all, that tells us we care about time. Now, time, generally speaking, will be relative to whatever the problem is. In this case, if we're dealing with speed, chances are we're going to be dealing with things like miles per hour or kilometers per hour, so we could deal with hours here. So let's assume that our answer is going to be given in hours, some number hours. Now, we also know that we're given some distance. There's going to be some value of distance, which is 26% longer, whatever that means, so that's going to be in kilometers. We also know his average speed will likely be in kilometers per hour. So if we're working backwards, we know that there has to be an hours in the numerator here. And if we're talking about speed, that means there's going to have been some kilometers in the denominator, right? Kilometers per hour, because there's no other place there we could have gotten hours or kilometers from. Right? Now, since it's kilometers per hour, this is always going to be 1. And there will be some number here. Also, if there's only an hours in the numerator here, that means there had to have been an hour here. That means we had to get rid of this kilometer. I'm sorry. There's only hours here. So we had to have gotten rid of this kilometer, which would have been something over here, some number over 1, I guess, over nothing. So some number of kilometers times 1 over some number of kilometers is going to give us some set of hours. Now, we're looking at ratios here. So it's not like we can plug in numbers to figure out the ratios, but there's not really much of a need to do that. And I think that's probably the most difficult part of this problem to conceptualize, is we're not really looking for a value of kilometers or kilometers per hour. We're looking for the ratios of them. So we know, since it's 26% longer, there's a couple of different ways that we can go about doing that. First of all, this is going to be percent change distance, and this is percent change in speed. Okay, so there's a couple of ways that we can go about determining what the percent change is going to look like from the old to the new. We know it's an increase, so it's going to be greater than 1. Well, I'm sorry, we'll get to that in a second. There's a couple of ways we could figure that out. So we can take some number, multiply it by the percentage, which in this case is 0.26. Let's say that equals triangle, and then the final value would be whatever was originally plus triangle. Okay, so if this was some kilometers per, or if this was some value for kilometers, and it's 26% longer, if we wanted to see what 26% longer looked like for that original value, we would take that original value times 0.26, which is this, and then add those values together. Now the other way of doing it, since we're looking at a percent increase, these are going to wind up being the same thing. If we took the original and just multiplied by 1.26, those mean the same thing. Okay, so what that means is what we can plug in for kilometers, since we're only looking at ratios at this point, is 1.26. If we do the same thing for change in speed, this would be 1.4 or 1.40. When we go through this process, 1.26 times 1 divided by 1.4, etc., this becomes 0.9 hours. Now the thing to make sure that you're okay with is that this is not our answer. We're not looking for 0.9 hours. This is just the percent change overall. If we're looking for the time reduced, And since this is a rate, it's out of 100 or out of 1, that'll be 1 minus 0.9 hours, which is 0.10%.